We now learn how to find the modulus of a complex number, and for that we're going to work through the two examples that we have here. I'll start by moving this question to the side, like so. The first question we have here, we have to find the modulus of the complex number z, which equals to 3 plus 4i. Now to find the modulus of any complex number, here's what we do. The modulus, which is written as z in between two vertical bars, a bit like an absolute value, is equal to the square root of the real part of the complex number squared, so that would be 3 squared, plus the imaginary part of the complex number squared, so that would be 4 squared. And that equals to the square root of 3 squared, which is 9, plus 4 squared, which is 16. In turn, that equals to the square root of 25. Finally, the modulus of this complex number z is equal to 5. And that's the final answer. You've probably noticed that this is very similar to the method we use for calculating the magnitude of a vector. And in fact, the graphical interpretation of this result is also very similar. Indeed, if we were to draw this in a complex plane, so I'd have an imaginary axis as well as a real axis. So that's real, that's imaginary, that's 0, 1, 2, 3, and so on. Then the complex number z equals to 3 plus 4i is the point in the complex plane whose real part is equal to 3 and imaginary part is equal to 4. So on this rough sketch, that would roughly be here. So that's the complex number 3 plus 4i. And the modulus of 5 here tells us that the distance between this point and the origin, 0, is equal to 5 units of length. In other words, the length of that red line segment equals to the modulus of 3 plus 4i. Okay, now that that's said, let's look at the second example. In this case, we need to calculate the modulus of the complex number z, which equals to -1 minus 3i. Well, the method is still the same. We can go ahead and write that the modulus of z is equal to the square root of the real part of the complex number squared, so that's -1 squared plus the imaginary part of the complex number squared. So that would be -3 squared. That's equal to the square root of -1 squared, which is 1, plus -3 squared, which is 9. Finally, the modulus of this complex number is equal to the square root of 10. And that's the final answer. And we could add this complex number to our diagram here. So the complex number -1 minus 3i has a real part of -1 and an imaginary part of -3. So that's roughly right here. So that's the complex number -1 minus 3i. And the modulus, which equals to square root of 10, would be the distance between 0 and this green point here. And that's equal to the square root of 10, which is the modulus of the complex number. In general, given a complex number z that's equal to a plus ib, its modulus, written as z between two vertical lines there, is equal to the square root of a squared plus b squared. And there we have it. We now know how to calculate the modulus of a complex number. And that's it for this tutorial.